At this point, I'd like to take some questions from the audience. I see some, it looks like there's a bit of a wire on that microphone up there, so maybe if somebody has a question, maybe I can get them to talk into the microphone. Does anybody have a question for our expert panel? Oh, that works. I see Ellen. I was speaking with Ellen. Ellen has a challenge question for our audience.
Challenge question.
And she wasn't sure whether she should ask it.
Are we allowed to phone a friend or use the internet?
I'm going to ask Ellen. Please raise your concern and let's hear how these gentlemen address it.
I don't know, Joseph. You're going to owe me a drink. I think you guys already answered it. We were just we wanted to hear what you were talking about in terms of active and passive balancing. And also just how the names came about, like why it's called passive, why it's called active. Have you ever seen any stranger, newer ways of doing cell balancing, even more expensive and crazier ways, and what you think about that in general?
Sure. So I mean, I think the terms came about from a marketing guy who's trying to sell active balancing. Would be my guess, because that's how it's named. So, and where we've seen its use is in applications where you're running continuously and you don't get all the way to fully charged and fully discharged. In terms of, to your question of have we seen even more esoteric ways in order to do balancing, what we have seen is applications where you get into hybrid systems, and so then you're combining other energy storage systems with your battery. And so then you can start using, so for example, we have an application where to enable lead acid peak balancing on a 6 megawatt hour battery, we have 3 strings, and we actually have these massive bolt switches that you take out one string at a time, and then we actually use a bitrode power supply in order to peak charge each lead acid string one at a time. So that is definitely some sort of active balancing, and definitely more expensive than a couple transformers and LTC 3300s. So we got other things in the works too.
Well, I would say the passive and active balancing, actually the names in this case actually fits pretty well. A passive is where you just discharge through a resistor and there's really no active anything going on. So you're dissipating energy through a resistor, it's passive. Active, you actually have to transfer energy through capacitive or inductive. Active circuits, I mean active balancing is, the idea's been around for a while. Conceptually, I don't think anybody has really had an effective, well, production active balancing system. And if you look, most of the initial suggestions use something like cell-to-cell transfer or something, and that in any reasonable model is completely inefficient because you don't typically have a need for charge right next to the cell right adjacent to you. Your charge has to be moved across the pack. And so you're just basically passive balancing through an active method. So what we really looked at is how can you efficiently move charge from where it is to where it needs to go, maybe in a 2-step process, and minimize the amount of charge moving. But so it's a very early stage for active balancing, but I think if it does become widely accepted and mainstream, it'll be through a method similar, I think, to what we're doing now.
You know, we did a military submarine battery management system design, and it had really strict requirements about being able to control each cell and drop each cell to the system and so forth. And so that battery management system actually had a little linear regulator on each cell. So it was like a little tiny power supply for each cell. And so that's you know, another way to go on battery management system. Not generally cost effective, but when you got one battery in a submarine, you know, hey, it's justified.
Are there any other questions?
Oh, thank you. Here's a situation you mentioned about the active balancing. The price is going to be changed from the $2 to $4. My question is does the battery consistency will influence the cost change?
Say it again.
The battery consistency.
Consistency.
I mean, if the battery keep if the battery the same,
Yeah.
but the battery consistency is different. You're gonna
The
need-
primary determinant of that cost is going to be the magnetics of transformers and the switches that you use. So it's going to be dictated by the amount of current you plan on moving around. So, for example, if you have a 10 amp requirement for active balancing, that's going to dictate your cost as opposed to a 100 amp. I mean, a 1 amp, excuse me, or something like that.
Okay, so the battery consistency is not a key point to
No,
choose then.
no.
All right. Thanks.
So battery consistency, you mean like how unbalanced the battery becomes, basically? Yeah, I mean, the amount of unbalancing that you might get might drive a balancing current requirement. But at the end of the day, once the electronics are in there, you can run active balancing continuously, if so desired. And so it'll continuously be shuttling charge and getting the battery back in balance.
But I would say with regard to consistency, there are a couple different ways we approach active balancing. And how you decide to approach it might depend on what the assumption is behind your variation in capacity. That is, if you assume that your capacities are going to degrade in a consistent fashion and you'll end up with maybe some sort of a normal distribution of capacity variations over the stack, that would be a different assumption than, for example, if you thought, well, most of my cells are going to stay pretty constant with a couple that will drop out, and I have to be able to compensate for those. So you may approach those two different problems differently. If I have a normal distribution of capacity variation versus I have a couple weak cells and I need to account for that possibility in my system. So that might be a quality issue or something like that. But those two problems, you might look at them slightly different in how you approach it. But I would say we offer a couple approaches to it. And I think either of those would probably,
His question just gave me a new idea. So battery consistency. So what if you took a really old battery that was like a decade old and you sprinkled in a bunch of brand new cells, right? Like passive balancing would be a horrible process for that because you'd never get access to the new cells. You'd still be limited by the worst cells. But with active balancing, you could get some system level upgrade just by sprinkling in some new cells through the system, and they would top up the worst cells of the decade old battery. So you could actually use active balancing to do a very cost-effective upgrade to an old battery.
Well, and I think this idea is behind some of the retrofitters who are planning on pulling off some of these hybrid batteries. Because the batteries in a car are at end of life at 80% of capacity, and so if you get a stack that's been abused and it's not effective to tear it apart, then you could potentially add active balancing to fully utilize all of the capacity of all the cells together, even if a couple cells have been pretty badly degraded. So I think there's a potential for that in the use of used batteries. Yeah.
Cool. Thank you. Any other questions from the audience?
I have two questions. One is based on the balancing. You guys just talk about what's the best way for Michael, for your opinion, using the voltage to balance or using the SOC value for each cell to balance. The second question is based on your background. How do you estimate, or how far I know there are so many papers on SOH and SOL, and what's the best technology we currently have on those two parameters?
Sure.
Thank you.
So to take each question, so the first is, should we do balancing based on state of charge or should we do it based on voltage? So if you were in, and the answer is, it depends. If you're in a section of the voltage curve where you have good voltage information, so for example, if you're at either the top end or the bottom end of a lithium battery, where there's a close relationship between voltage and state of charge, then voltage will actually give you better information because that's kind of the absolute correction on your state of charge algorithm. If you're doing passive balancing sort of continuously when you're operating in the middle range of a battery, then you're going to use state of charge because your voltage information in the middle range of a battery, like between 20% and 80%, it's pretty flat. In fact, it gets swamped by the hysteresis of just the voltage skin effect, switching between charging and discharging. And so voltage isn't useful for passive balancing in that range. So then you would use your state of charge algorithm in order to do it there. The second question of what's out there and what's the best approach for handling state of health and state of life calculation. So the best one I've seen is frequency response systems. So for example, there's one made by a company, a partner of ours, called ELSI. And what they do is they send out a current frequency that basically bounces off the battery and gives you a voltage response. And this allows one to predict in advance of a catastrophic battery failure. It can predict when a battery starts to fail. And so in a lead acid battery, it can detect dry out and sulfation in advance of that showing up in voltage and current characteristics. And on lithium batteries, it can measure your consumption of lithium, and your plate separation can be detected again in advance of that showing up in voltage or current, and it can basically detect a soft warning of, hey, this battery needs to be replaced. So that's the best I've seen in terms of measuring life fraction.
Thank you, Michael. We have time for one more question. If anybody has any more. Okay.
So with batteries, there are standard drive cycles and so on and so forth that you can test the performance of. Are there any specific test routines for management systems and there are optimization possibilities with your virtual platform to determine drive cycles, so to say, for the management systems? These exist.
I'm not sure I'm hearing the question.
He was asking if there's standards on testing battery management systems. I thought the standard was the Blooming Hill system, wasn't it?
Right. Bloomy's background is we've done electronics functional testing for many, many years. And avionics, engine controls, lots of different control electronics. And a BMS is, an example of a complicated set of control electronics. So standards, I'm not aware of standards. I would say the standards are set by the application and that it's being used for, and the customer and the specifications and so forth. There isn't a set of industry published standards for BMS testing.
Thank you.